All right, hello. This is video number 27. By the way, if you haven't looked ahead in the classroom, there's 36 videos for this class, so we're getting pretty close to the end. Video 27 is chapter 5, and this actually covers two sections, 6 and 7. And this is all about factoring trinomials. And I mentioned before that you're always going to, when you're factoring, always check for a GCF. And I'm going to do a few problems here that don't have one first, and then we're going to add a GCF so that you see what that looks like. And then what we did before, the last section, was for 4 terms, we used factor by grouping. Today, we're going to talk about what to do if you have 3 terms, and that is factor using X method. And then what's going to be coming up in the next video is if you have 2 terms, we have what are called special cases. And that is, let's see, factoring by difference of squares. Actually, that'll probably be its own video. And then we have sum and difference of cubes. Okay, so those are coming. And excuse me. And then we'll just throw out a whole big factoring thing. And it's your decision how you want to factor a problem. So you're going to always look for a GCF, and then you're looking at number of terms to decide how to factor. So today we're focusing on a 3 terms factoring by something using what's called X method. All right, so here we go. First thing you need to know, we are talking about trinomials. And usually those trinomials are in the form ax squared plus bx plus c. And we're going to see some that look a little wacky. So 5.6 is really if they're in this form all the time, ax squared plus bx plus c. However, there's actually kind of a strange offshoot of these where the exponent on bx must be half of the value of the exponent on the ax squared term to use X method. And so here's what I mean by that. You might see something in that form in the box, ax squared plus bx plus c. So the exponent on the bx is 1, and 1 is half of 2, the exponent on the ax squared term. So this you could use X method. If we had ax to the 4th plus bx squared plus c. Now, c is a constant, right? This is a number with no variable on it. Take a look here. The exponent of the bx term is 2, and this states that it has to be half of the exponent on the ax squared term. The ax squared is actually a 4th. 2 is half of 4. So you could use X method for a problem like that. What if you had ax to the 6th plus bx cubed plus c? Well, 3 is half of 6, so that would be okay. Here's where you couldn't use X method. Ax to the, well, let's make that a 4th. ax to the fourth plus bx cubed plus bx squared. First of all, notice that there is a variable on that C term. Oh, that should be a C. My bad. Sorry about that. On that C term, and that can't happen. That's C. So no variable here unless, it's a GCF, right? You could factor it out, but they need to be in this format to have this happen. So look very carefully and evaluate before you go any further. So we're mostly going to be focusing on these guys right here, but we are going to touch on a couple of these at the end. And this is actually 5.7. It's taking X method and going one step further with it. Okay. So your first example is going to look like this. We're going to say factor 3x squared minus 17x plus 10. And just to, again, remind you, this is in the form ax squared plus bx plus c. So in this problem, a is 3, b is negative 17, right? Because this is a positive bx, and this is not. So the b is actually negative 17, and the c is 10. All right, so what we're going to do with that is you're going to create an x, and this is going to happen every time. So notice you have 3 terms. It's in the right form. You're going to make an x, and in the top of the x is going to go a times c, and in the bottom is going to go b. And you can just pluck those out of the equation as long as you should check to make sure you have no GCF first. And we're talking about in that problem, well, we have a 3, a 17, and a 10. 3 and 17 are both prime, so that does not have a GCF that we could take anything out of. And you have to have an x in every term in order for the variable to be a GCF, and it's not. So we do not have a GCF in this one. Okay, so you're going to go ahead and multiply a times c. Well, a is 3 and c is 10, so a times c is 30. And if there were negatives on here, you would take those two, okay? And then b is negative 17. All right, so what I like to do is I'll highlight these areas for you. So this area and this area, we're going to put 2 numbers in there, and those 2 numbers, actually, let me just, so these 2 numbers are 2 specific numbers. The numbers you fill in in these areas must multiply to equal a times c and add to equal b. Okay, I'm going to continue to highlight. That whole thing should be highlighted. Okay, so we need to put 2 numbers in the sides of this thing that multiply to 30 and add to 17. And for those of you who have good multiplication skills, this is going to be simple. For those of you that don't, this might be a little bit difficult. But what you can do is just list factors of 30 over here. Uh-oh, I don't have enough room. Factors of 30. Factors of 30 are 30 times 1, 10 times 3, 5 times 6, 15 times 2. I think I found them all. And then you're going to look at, just look at them one at a time. Will this one, 30 and 1, ever add to a negative 17? And we can deal with signs later, but add or subtract. This will give you a 29 or a 31. So this one won't work. 10 and 3 will add to 13 and subtract to 7. So that one won't work. 5 and 6 will add to 11 and subtract to a 1 or a negative 1. So that one won't work. 15 and 2 will add to 17. So those are the 2 numbers we're going to use. And if they have to add to a negative 17, they both have to be negative. And when you multiply two negatives together, they multiply to give you a positive 30. So that's the only combination of the factors that's going to work for this. So that's the first thing you've got to do. Put the numbers, I'm rereading what's in the highlighting. The numbers you put in these areas must multiply to equal A times C, which they do, they equal 30. And they have to add to equal the B, which is negative 17. And they do. And that's the only combination of numbers that's going to do that. So deal with the numbers first and then the signs second. And then after you do that, you're going to divide each of the side numbers by A, the value of A, and reduce if possible. Okay, so my A term here is 3, right? So I'm going to divide by 3 and divide by 3. Now I can't reduce a negative 2/3, so I'm going to use that. But negative 5 over 3, or 15 over 3 becomes negative 5 over 1, and I'm going to use that. And here's how we're going to use those. Each of those fractions become a binomial. I'm just going to write this way down here. Each of the fractions become a binomial factor. Binomial factor where the bottom or the denominator comes up and gets a variable, and the top or the numerator becomes the constant. Okay, take a look at that statement because that's a big statement. And then, how can I view this whole screen? I need to change we need to see more. So we're going to zoom to the entire page. Okay, so again, take a look at the statement. I'm going to highlight it in green because it's a biggie. Each of the fractions, and by the fractions, I'm talking about these up here that we made, become a binomial factor, which means they're going to look like x plus 5 or 2x minus 6 or something like that, where the bottom number comes up and gets a variable. So let's start there. Bottom number comes up and gets a variable. So I'm going to start with this guy over here, the negative 5 over 1. The bottom number is going to come up and get a variable. Here's my binomial factor. It's going to come up and get a variable, 1x. Comes up here, gets a variable. And then the top number becomes my constant, minus 5. Okay. Second parenthesis or circle over here is a binomial factor. The bottom of a 3 is going to come up in the front and get a variable. The top number becomes your constant. And you're done. You can check it if you want. Here, let's check it. I'm going to move some things out of the way. Let's move that. Okay, and so this is done. This is my, oops. I want a purple pen. Okay, this is my answer. We have factored into a multiplication problem. How could you check it? Or you can check by foiling. And you should for the first few of these. I know a lot of you hate checking, but it is so worthwhile. So here, x times 3x is 3x squared. X times negative 2 is negative 2x. Negative 5 times 3x is negative 15x, and negative 5 times negative 2 is positive 10. Combine like terms in the middle, and I get 3x squared minus 17x plus 10. That's what we started with up here. And so in the purple box is the answer to that problem. That's the factored form of that problem. The reason we do this is so eventually we can solve for x and find out what x equals in this problem. But this is the process. All right, so keep that handy. I'm going to go to a dual page display and hopefully this won't get too confusing as we go. Go to a dual page display. Okay, so let me write down a new problem. That new problem looks like 2x squared minus 3x minus 2. All right, x method. You make your x. In the top of the x goes a times c, and the bottom goes b. I'm not going to list out my a, my b, and my c this time, but a times c is 2 times negative 2, so that's a negative 4, and b is negative 3. So that's how you're going to start every time. Then list your factors. Remember, of negative 4. So what's going to multiply to 4? Well, those options are limited. 4 times 1 and 2 times 2 are the only things that are going to factor to equal 4. And then which one of those will add or subtract to 3? Well, clearly, that's only this guy. So 4 and 1, they have to add to be equal to the negative 3 on the bottom. So negative 4 plus 1 would give us a negative 3. And they have to multiply to equal a times c. So if I multiply a negative 4 times a 1, I get a negative 4, right? So you have to make sure that both of those things happen. Again, that is the yellow statement over here. The numbers you put on the sides have to multiply to equal the top and add to equal the bottom. All right, after we do that, now we're looking at this step right here. We're going to divide each of the side numbers by the a value. The a value is 2, so I'm going to divide by 2, divide by 2. Well, I can't do anything with the left-hand side. Oh, I want a different color. I'll go red. So 1/2 doesn't reduce, but negative 4 over 2 reduces to negative 2 over 1. That's the number I'm going to use. 2 binomial factors, they're multiplied together. Bottom number comes up and gets a variable. So x minus 2. Bottom number comes up and gets a variable. So 2x plus 1. Done. All right. Let's do another one right on this page where you can see what's going on. Actually, I need to go get one because I don't have one written down. So let's go to varsity. We'll go to, I need to go back to 5.6. Give me just a hot second here. Got to find out. We need 5.6. Okay, factoring with X method. I don't know if I showed you how to do this before, but you're aware at the bottom of the problems, there's a print version, right? And you can click on that and it will give you all of your problems like on one sheet of paper. So let's see. I want to take, I'm looking for something that doesn't have a GCF in it. 2a squared plus 7a plus 6. 2a squared plus 7a plus 6. 2a squared plus 7a plus 6. Okay. X method. Make your X. A times C in the top. That's 6 times 2 is 12. B in the bottom, which is 7. And then if you need to list out your factors, we want something that's going to multiply to 12. So that's going to be 12 times 1, 2 times 6, 3 times 4. I think there's no more. And it's very obvious looking at this list that 3 times 4 equals 7. And everything's positive in this one. So now we have to divide by our a value, which is 2, right? So we're going to divide by 2, divide by 2. This one will reduce to 2 over 1. This one doesn't reduce, 3 over 2. Bottom number comes up and gets a variable, so 2a plus 3. Be careful with varsity too. When they use a's, make sure you use a's or else you're going to get the problem wrong. And then the right-hand side, 2 over 1, the 1 comes up. So this is a plus 2. And done. Again, I know these are working out correctly, but when you start these, it would be probably a good idea for you to go through and check. I'm not going to require that you do that, but let's just do that here. 2a squared plus 4a plus 3a plus 6. Look, it took me like 4 seconds to do that. 2a squared, I combine like terms, plus 7a plus 6. I have here what I started with here. So this is the factored form of that problem. So that's the answer, right? Okay, we're going to take now and expand this and do a couple more examples. I'm going to go back to one page. Oops, that's under view. Dual page off. And let's go out here and add a couple of problems. So this one is 3x cubed minus 15x squared plus 18x. And early on, I mentioned to look for a GCF. This problem has one. The GCF in this problem, if you look at all of your terms, you have an x in every term and a 3 can come out. And so the GCF is 3x. So the first thing I'm going to do is factor out the GCF. And so when I do that, 3x, I get an x squared minus 5x plus 6. And now you're going to x method only what's in the parentheses. And your 3x will stay out in front of your answer. So it's going to look something like that when you're done. So I x method. This becomes your ax squared plus bx plus c. This guy's essentially gone. It doesn't matter anymore. Try not to look at it. Cover it if you need to. A times c is going to be 1 times 6. So that's 6. B is negative 5. And then what's going to multiply to 6? So factors of 6 are 6 times 1 and 2 times 3, and that's it. Both of those will add to 5, so you need to be careful and creative. Now, if this number down here is negative, but this one up here is positive, that means you're multiplying numbers to get this. So these both have to be either positive or negative. And if they're both positive, you can't add to a positive. So they both have to be negative in this situation. And so the only way for us to have the signs the same is for the 2 and the 3 to give us the negative 5. 6 and 1, we'd actually be adding, and they would give us a 7. So just be careful when you have a 6 and a 5, because both of those could technically work. And now remember, you're dividing by the a value, which in this case is a 1. Which makes these simple, right? Because the 1 comes up and gets the variable. And so this is going to be an x minus 2 and an x minus 3. And this is your answer. Okay? So that's an example of taking out a GCF. That one, it specifically had a number and a variable. However, it is possible. Oh, I want to view. Take this off of. We'll go to that. Okay, so here's another one with a GCF. Let's see if you can identify it. So this is a new problem. So we have 12z to the 4th minus 7z cubed minus 10z squared. And looking at that, the first thing that should go off in your head is that you have a z in every single problem, right? So I have a z squared, a z cubed, and a z to the 4th. So I can at least take out a z squared because that's the smallest variable term. And so let me do that. So we'll take out a z squared. Of my coefficients, though, I have a 12, a 7, and a 10. And even though the 12 and the 10 have a GCF, the 7 doesn't. So there is no numeric GCF in this problem, just a variable one. So this is going to decrease all of our z's by 2. So 12z squared minus 7z minus 10. Now remember, this right here is the problem that I'm going to use, and this essentially is gone. Okay, so now when I x method, a times c is a negative 120. B is negative 7. Well, things that are going to multiply to 120. So factors of 120. Obvious, 12 and 10. I actually grabbed my calculator and did this one, and I found out that 15 and 8 are factors. But you can start in your calculator. Just be really thorough, like 120 divided by 2. Well, that would be what, 60. So 2 and 60. And then 120 divided by 3. Well, that would be 3 and 40. That means 4 is going to go in there 30 times. 5 is going to go in there, I don't even know how many times. 120 divided by 5, 24 times. And then you can, keep on going. Then divide by 6. Well, 6 is clearly going to go in there 20 times, right? And then I don't think 7 will go in there evenly. And then you get to your 8 and 15. So it might take you a while to come up with the ones that you need, but be very specific so you don't skip it. So I'm going to go 8 and 15. Now, this number at the top has to be negative, which means my signs have to be opposite on my two red numbers. The one down here is negative, so my bigger one has to be negative. Negative 15 plus 8 is negative 7, so that will happen. And then don't forget to divide by a, so we're dividing by 12. And in this case, these are both going to reduce. 4 will go into both 8 and 12, so this is 2/3. And 3 will go into both 15 and 12, so this is 5/4. And so this guy's going to come down. And then the two binomials, left-hand binomial is going to be 3z plus 2. Right-hand binomial is going to be 4z minus 5. Okay? All right, couple more we have to talk about so that you can do 5.7 as well. You have enough information to do 5.6. If you want to break this up into a couple of things for you, you could pause and come back. I'm going to go ahead and add those 3 extra examples for you right now. So here's the next example. What if you have one that looks like 3x to the 5th minus 3x to the 4th y minus 36x cubed y squared? Well, this guy kind of has a couple things happening. The first is a GCF. And if we look, we know a 3 is going to go into both 3, and 36. Excuse me. And then we have an x to the 5, x to the 4, x to the 3. So x to the 3rd can come out. And then we have no y's in this first one, which means we have no y as a GCF. So 3x to the 3rd is my GCF. That's going to leave me x squared minus, I take a 3x cubed out of this middle term and I get xy. Take a 3 out of a 36 and I get a 12. X cubed is gone. Y squared. All right. So this is actually something else that can happen. So it changes your general form from ax squared plus bx plus c. Well, now you have ax squared plus bxy plus cy squared. And the only thing it does is when we take this first one on top, the ones you've done, you get 2 binomials where you have an x in this term in the binomial right here. Well, now your first term is going to have an x and the second term is going to have a y. So you're going to have an x and a y, an x and a y. And you'll see all we're going to do is just add a y to that second constant, what we had before. All right, but we're going to do these exactly the same way. So this is still your a, your b, and your c term. A times c is negative 12, b is negative 1. Things that are going to multiply to negative or to 12 are going to be 12 times 1, 2 times 6, 4 times 3. And it's pretty obvious here that the 4 and the 3 are going to be the numbers that we need. Remember, we're going to divide by the a term, which in this case is 1. So divide by 1, divide by 1. And so the 3x cubed is going to come down. But now when this becomes your binomial, we're going to have the 1 comes up and gets the x. So this is an x plus 4. That's normal. Now you're just going to toss a y on the end. Okay, so this gets the first variable. This one gets the second. This gets the first variable. This one gets the second. So this is going to be the second one is going to be 1x plus 3y. Okay. And again, remember, check these things. Okay. So you would leave the 3x cubed alone and you'd FOIL. X times x is x squared. X times 3y is 3xy. 4y times x is 4xy. And then 4y times 3y is 12y squared. Combine like terms in the middle. So we have x squared plus 7xy. Uh-oh. I forgot a minus sign somewhere. Totally forgot a minus sign somewhere. All right, and it's back up. Let's go back up into here. I have 4 and 3. Those are going to give us a 7. I need 4. Negative 4 plus 3 will give us a negative 1. So you can see where these little minuses will come into play. And here's why you should check. Because now this guy is a negative and this guy is a plus. So almost all my work was right, but you would get this wrong in varsity with that one little minus sign wrong. So now when I FOIL, I get x squared plus 3xy minus 4xy minus 12y squared. All right, now let's get rid of this. Go back to here. So combining like terms, I get a negative xy minus 12y squared. So this is the same as this in red up here. And then if we redistribute the 3x cubed in, we would end up with the original problem. Okay, so what is the actual answer in all this mess? Well, it was this. So the answer, 3x cubed times x minus 4y times x plus 3y. That's why it's a good idea to check, people. All right, so that's if you have multiple variables. There's a bunch of those in 5.7. Just add the second variable into the second part of the quantity. All right, the last two examples are similar, and it goes back to what I mentioned back on this page. Yes. So you can use the x method as long as the exponent on your bx term is half of the exponent on the ax term. So let's take a look at what's going to happen here. I'm going to add a screen, and here's your next example. It looks like 6x to the fourth minus 7x squared minus 5. So notice first that the 2, the exponent on the bx, is half of this one, which means I still can x method. This is still my a. B is negative 7. C is negative 5. So A times C, everything else happens the same way. So this is negative 30. My B term is negative 7. And I want factors of negative 30 that are going to add to negative 7. So what multiplies to 30? Well, 30 and 1, 15 and 2, 5 and 6, 3 and 10. Which ones of those can I make equal a 7? Well, it's going to be this guy, right? 3 and 10. So I have a 3, I have a 10. It's got to be a negative 10 plus 7 or plus 3 to give me a negative 7. Don't forget that you need to divide by the a term, divide by the a term, divide by the a term. So when I reduce on the left-hand side, 3/6 will become 1/2. And negative 10 over 6, a 2 goes into both of those, negative 5 over 3. And so now what you're going to do, normally, you would have 2x plus 1 and 3x minus 5. But if you check this and you multiply these, you only get 6x squared, right? And you need 6x to the fourth. So how are you going to make that happen? Well, these two variables simply have to have the exponent that matches the b term. That will happen every single time. In your parentheses, the exponent in the binomials will equal the exponent on the b term. All right, so one more example similar to this one. Also, just that's your answer. I didn't really tell you that. I figure you know, and then some kids say, I'm not sure what the answer is. It's always your factored form. Remember, you're factoring into a problem that goes from addition and subtraction. You're turning it into a multiplication problem. That's when you factor. It becomes a multiplication problem. All right, last example. Here's your example. 8a to the 6th plus 6a cubed minus 5. All right, so again, the 3 is half of the 6, so we can use X method. A times C is negative 40. B is 6. Things that are going to multiply to 40 are 40 and 1, 20 and 2, 44 and 10, 5 and 8. There's probably a few more, but I need to get to a 6, and a 4 and a 10 will get me to a 6. This guy up here is negative, so my signs have to be different. 10 minus 4 gives me a positive 6. So those will multiply to negative 40 and add to a positive 6. Don't forget to divide by the a term and reduce. So the left-hand side will reduce to negative 1/2. The right-hand side, each reduces by 2, goes to 5/4. And again, write this out how you normally would. This would be 2a minus 1 and 4a plus 5. And then just make sure the exponents in the binomials match the exponent on the b term. So this would be a cubed, this would be a cubed. And that's how when you multiply, you get 8a to the 6th and blah, 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 right? So this is your answer. And you should be good. All right, so that's factoring with the X method. And remember, this is for trinomials, which means you have 3 terms, right? So just kind of a little review there. All right, toodaloo.